Hey, this is Mr. Aiden. This is our second video on Unit 5, Analytical Applications of Differentiation, and we're talking about the extreme value theorem, baby. We're getting extreme right now, so just watch out because you're going to get extreme. The extreme value theorem. So let's talk about my extrema. Here we go. The extreme value theorem. What is the extreme value theorem? The extreme value theorem is it's a theorem that guarantees that there will be a maximum and a minimum value for a function under certain conditions. Our first condition is that the function needs to be continuous. It needs to be continuous on a closed interval between a and b. Okay, and so you can see how. Let's talk about my a being a 0 here. My a being 0, and my 5 is going to be my b. So we are continuous all the way from a to b. We are continuous. That is the first thing in the extreme value theorem. So that's our first condition, our first procedure. The next step is to determine all the what we call critical points in the given interval and evaluate the function at these critical points and at the endpoints. Okay, so you can see where do we have the minimum value? Well, this guy down here would be what we call the absolute minimum. Why? Because that is the lowest y point, and so at f of 5 at -1, that's the absolute minimum, which means all the way up here is the absolute maximum. The absolute maximum. So we can see how the absolute minimum is the lowest point, the absolute maximum is the highest point, which means this point right here is what we call a relative minimum. Okay, and you can have relative mins and maxes. We also call this local mins and maxes. So this isn't the absolute minimum, but it's a local minimum between a smaller interval right here. Now, how do we know we have a minimum or a maximum? Well, if we take the derivative of my function and that derivative of my function is equal to 0 or it is undefined. Okay, it is undefined. It is or non-differentiable. We know we have what's called a possible critical point. Okay, a possible critical point. And when we talk about the extreme value theorem, we also have to not only take a look, you can see how we have this slope is going to be equal to 0. So f prime of 1 is going to be equal to 0, which means that is what we call a critical point. Critical point. You can see right here at f prime of 2 that is not differentiable. Not differentiable, which means that because it's this pointy thing, it's still continuous, but it's non-differentiable. And so we have a critical point right here. We also have to include our endpoints of our intervals. Our endpoints of our intervals could be minimums and maximums as well. And so the critical points are ones that are 0 or non-differentiable, and we have our endpoints as well. So let's kind of investigate one of these types of problems. So here it says find the minimum and maximum values of this function f of x is equal to sine of x plus cosine of x between the interval of 0 and 2 pi. And so what do we want to do? We have f prime of x is equal to the derivative. What's the derivative of sine of x is cosine of x plus cosine of x is minus sine of x. Okay, and we're going to set that equal to 0, which means when is sine of x equal to cosine of x? Because if we do our algebra here, so when is sine of x and cosine of x equal? Well, if we think about our unit circle, at pi over 4, we're positive root 2 over 2 and negative root 2 over 2. Oh, sorry, positive root 2 over 2 and positive root 2 over 2. So sine and cosine are the same. We also have over here at 1 pi over 4, 2 pi over 4, 3, 4, 5 pi over 4. At 5 pi over 4, we also have the sine of 5 pi over 4 is negative root 2 over 2. Cosine of pi over 4 is negative root 2 over 2. So that is what we call our critical points. So what are our critical point values? Critical point values. Well, we have 0, we have 2 pi, because we have to use those endpoints, okay? And we also have pi over 4, and we have 5 pi over 4. Okay, so we have these critical values. So now when I plug this in my original function, I have sine of 0 is 0, plus cosine of 0 is 1. So f of 0 is equal to 1. Okay, so when we plug in 1 there. So when we plug in f of pi over 4, we're going to plug that in my original function. So sine of pi over 4 is root 2 over 2, plus cosine of pi over 4 is root 2 over 2. So what's root 2 over 2 plus root 2 over 2? That is square root of 2. And so now I'm going to plug in 5 pi over 4. And so when I plug that in, we're going to plug that in the original function. Sine of 5 pi over 4 is negative root 2 over 2, plus negative root 2 over 2, which ends up becoming negative root 2. And of course, f of 2 pi is equal to 1, same as when we were back at 0. So if we think about this, we know that this is, the square root of 2 is like 1.41 or so, 1.414. Negative is negative 1.414. So what is my maximum value? My maximum value is right here. My maximum value would be at pi over 4 and result in root 2. My absolute minimum value would be right here at 5 pi over 4, which results in negative square root of 2. So that helps us find out our minimums and maximums. So let's try one more problem. So here we have an interval of negative 2 to positive 2. And so what we want to do, obviously, right off the bat, is take the derivative. And so we have, we're going to use the power rule here, minus 9x squared. And we're going to set that equal to 0. We're going to set that equal to 0. So we got to do a little bit of factoring here. Let's take out an x squared, and we end up getting 4x minus 9 is equal to 0, which means x could equal 0. X could equal 0, has a multiplicity of 2. X could equal 9 over 4 there, 9 over 4. And so what are my critical points, my critical values? My critical values, okay, remember, we have to, in the extreme value theorem, include negative 2 and positive 2. Okay? And so negative 2 and positive 2. And we have 0, and we have 9 pi over 4. Well, 9 pi over 4 is equal to 2.25, so that's outside my interval. So that's not going to come into play here. We have these two values. So I'm going to plug f of negative 2 in my original function. So I get, I do that negative 2 to the 4th power minus 3 times that negative 4 to the 3rd power minus 1. And I end up getting 39. Okay? I'm going to plug in f of 0. And when I plug in f of 0, I get 0, 0, I get negative 1. And I'm going to plug in f of 2 into my original function. F of 2 equals negative 9. So now I can take a look. Where is my absolute maximum value? Well, that is at my endpoint right here at negative 2. That's the absolute max. And where's my absolute min? Absolute min is right here, which means we had our endpoints ended up being our both maximum and minimum values, our critical points, and that shows the importance of the closed interval in determining which values to consider for your critical points. So that's the extreme value theorem. I hope that helped. Do your self-assessment and chill like a vill, okay? See you guys. Bye.